All right, we're looking at section 812 in pre-calculus. We're going to do some modeling with periodic functions. And so we're going to go through this one together. The first problem says, Brielle and Elaine always travel to Sunset Beach together for their summer vacation. Every year they return to the same section of beach and spend their time around the pier. Elaine notices that the water rises and falls on the post of the pier. She thinks that the height of the water can be modeled using a sinusoidal function. Brielle is snorkeling and notices that the pier posts are slimy up to the lowest level of the tide, which is 2 feet for this particular post. Since Brielle and Elaine are on vacation, they have nothing better to do and find out that there was a low point on the post at 8 a.m. and a high point 40 inches higher at 2 p.m. So the first thing we want to do for all these problems is to write an equation to model the height of the water relative to the post as a function of time, where t equals 0 represents 12 o'clock midnight, and h of t represents the height of the wave water in inches. So I would definitely suggest sketching a graph first. So as we read the problem, the lowest level of the water is 2 feet. So I'm going to put something at 2 feet. And then at 8 a.m., there is a low point at 2 feet. And actually the next one's in inches, so I might go back to my 2 feet and call that 24 inches. And then at 2 p.m., there is a high 40 inches higher. So I'm going to call that 64. So I got the 24 from the lowest level being 2 feet on that post. So it's slimy up to 2 feet, meaning it's always wet below that. And then 40 inches higher would be 64. And then at 2 p.m. So as I'm reading this question, I'm not just writing 2 p.m. I might start counting in 24 hours. And instead of calling that 2 p.m., I might call that time like 1400 hours. And that is a high at 64. And I think that's going to help me probably find some of my information. If we use symmetry, we are going to use a sinusoidal function. We think that they're probably 8 a.m. to 1400 hours, and then our next low, according to symmetry, should be here at 20 hours. And then we can probably start working backwards from there. But that's the information I know. So let's start writing what we do know. I'm going to start with my amplitude. If my low is 24, my high is 64, and I have a difference of 40 inches, my amplitude is half of that, so 20. And then that kind of leads me into my midline as well. And I like that we write midline in pre-calculus. My midline is going to be right in between there. And that should be at 44. So I've already got, as I'm writing my equation, a sine cosine b x minus h plus k. I've got my a, I've got my k, and then we got to start working from there. So I think the next thing we should look for is our b value. And if our period, in this case, from 8 a.m. to 2000 hours is 12 hours, and our equation PB equals 2 pi, and P is 12, my B value should be 2 pi over 12, or pi over 6. So now I've got that one done. And now I just need a horizontal shift. And I kind of need to decide, what am I calling this function? I think it would show good understanding if you could just put a 14 right there and call it a cosine function. I think it would show a little more understanding if you kind of worked backwards and said 6 hours before this. So my graph's going to get a little scrunched here because I put 8 a.m. there. But I think 6 hours before this at 2 a.m., there should also be a high. So if I were to redo the graph, I'd probably put 2 a.m. in there as well. So I think this could be a 14 or a 2. And I really like to use the first one I come to, so in this case it would be the 2. So I think a final equation would be y equals 20. And I like cosine because I've got that high value at 2. Cosine, and then we are going to put our b value, pi over 6, right here in front. X minus 2 plus our midline of 44. So that is our equation to model the height of the water relative to the post. I like it. All right, as we look at part B, I cleaned up my graph here. At 11:30 a.m., the girls want to take a walk on the beach, but decide to wait until high tide. What was the height of the water at 11:30 a.m.? So we can get an idea of that. 11:30 a.m., somewhere in between here, so it's probably pretty much in the middle. But really, to find the height of the water, this function y represents the height of the water. So if I just put in the value 11.5 for x, then I should get the height out. So y equals 20 cosine pi over 6. And if I go 11.5 minus 2 plus 44, I should get that value. And I think I get out the value of 49.18 from my calculator. And that's in inches. All right, and the last one says, all right, and the last part of this problem says, Brielle's little brother Sean is 2 feet 7 inches tall. When is the first time after 8 a.m. that the water will be over his head if he plays next to the post? What do you think? 2 feet 7 inches, I think we're going to want to put that into 31 inches. So here's 24, here's 64, so 31 inches is somewhere in here. Here's 8 a.m. So when is the first time that it's going to be over his head? So my suggestion on this one is to again use our calculator. When you've got a couple options, we really want to set this, I think that'd be a good idea to go through this whole problem. Set it equal to 31 and kind of start solving. 31 equals 20 cosine pi over 6 x minus 2 plus 44. So subtract that 44. So I get that negative 13 equals 20 cosine pi over 6 x minus 2. Divide by the 20. Negative 13 20ths equals cosine pi over 6 x minus 2. So here's the part where, like, we could use a calculator, but I think, also understanding what our calculator is telling us is a very good idea. So if I take the cosine inverse of negative 13 over 20, and then I divide by pi over 6, and then I add 4. I think we can follow that solving. I get x equals 6.35, and x is hours. But where's that on my graph? That would be right here. So remember, when we type cosine inverse, our calculator is limited. So how could I use this information to solve the problem I need? And I think the right answer is symmetry. If this is 6.35 hours, right here, then my distance there is going to be 1.65. And then my distance here should also be 1.65. So my answer should be 9.65 hours. But they want the first time, and I think I want to answer in time. So that's going to be 9 o'clock, and then 0.65 hours is 39 minutes. So I think the right answer there is 9:39 a.m. is when we should probably be watching for little Sean to be going under the water. Keep this page to refer back to as you're working on any of these application problems. Just follow the steps. Make a graph, What do you got? Set it up.